formula for lateral area is going to be the perimeter times the height. Since in this problem we have a cube, we're talking about all the sides are the same length. So we want to find the perimeter is going to be x 4 times, making it 4x because it's x plus x plus x plus x plus x. And then we have our height, which is the distance from base to base, which is also another x. So we take all of these values that we know, substitute them into our formula, and we end up getting 4x times x. And this is going to be equal to 576. So 576 is equal to 4x squared, because x times x is x squared. Divide both sides by 4. This leaves us with 144 equals x squared. You take the square root, which means x has a value of 12. So each edge has a value of 12. So in this problem, it's very similar to the last one. This time we know the surface area, which is meaning total, is 8,000. So we're going to have this is equal to our perimeter. Once again, since it's a cube, x 4 times gives us 4x. The height is also x. And then we're going to add it with 2 times the area of a base. This should be a capital B. And area of the base, that means we have this times this, which gives us x squared. In solving, we go ahead and multiply up our terms. So this becomes 4x squared plus a 2x squared. These are like terms, so we can add them up. And that's going to give us 6x squared. Now we're going to divide both sides by 6. So this gives us 13,333.3 repeating. This is equal to our x squared. And then you take the square root and we get x is going to be about 115.47, and we're in meters. So in this one, we're using the cylinder, and we're going to find the lateral area, surface area, and volume. From the problem, we know that it has a diameter of 10 centimeters, which means the radius is equal to 5. And then we also know we have a height of 19. And then we're being asked to leave pi in their answer. So for the lateral area, we're going to take 2 pi. We're going to multiply by the radius as well as the height. So 2 times 5 is 10. 10 times 19 is going to be 190. And we leave our pi in our answer. That is the lateral area. Then we're going to go ahead and find the total surface area. So this is going to be 2 pi. The radius we said is 5. The height we know is 19. And this time we're going to go ahead and add it with 2 of the bases. The base is a circle, so that's where this 2 pi. And then we have the radius squared. Okay, we solved a moment ago. We know this is going to be 190 pi. And we want to add that. 5 squared is 25. 25 times 2 is 50. So this is going to be 50 pi. 190 pi plus 50 pi comes out to 240 pi. And that's going to be our answer for the total surface area. And then we have our last one, which is talking about volume. Volume is going to be pi times the radius squared, which we know is 5. So 5 squared times the height, which is 19. So 5 squared is 25. 25 times 19 comes out to 475, and we leave that pi in our answer. So we have our volume. And all of these are in centimeters. So volume centimeters cubed, surface area is centimeters squared, lateral area is also centimeters squared. So in this problem, the first thing we want to know is how many bags of concrete mix Maggie needs. So we need to find the volume. Volume is going to be equal to the area of the base times the height. So for this problem, we have our area of the base, which would be a rectangle, 30 times 17. And then we have the height of our prism, which is 0.75. Make sure you include that decimal. Here, you can type this into your calculator, and you're going to get 382.5. And then we have the next part where it says each 50-pound bag of concrete mix makes 4.2 cubic feet. So we want to take our volume and divide by 4.2. So the 50 pounds there, that's just telling the weight of each bag, which is how much each bag mixes there. It's going to make that 4.2. So we want to divide by 4.2, and that's going to give us 91 point something, which means we have to round up, making it 92. She's going to eat 92 bags, and yeah, she'll have some left over, but that's okay. The next part of this problem is then asking us to find the surface area of the outside of the open box, which means there's no lid. So when we're finding the surface area, we don't want lateral because lateral just gives us the sides. And we don't want total because that gives us the whole bottom part as well as the whole top part. So what I'm going to do is I'm going to take the surface area, the total formula, which is perimeter times the height, plus, instead of 2b, it's just going to be 1b because I just need one base. So from here, our perimeter, this would be 30 plus another 30 gives us 60. 17 plus another 17 gives us 34. And we're going to take this sum and multiply it by the height, which is 0.75. And then we're going to add it to the area of the base, which is 30 times 17. Go ahead and simplify that, and you should get 580.5. This would be feet squared. Okay, so on number 7, we're asked to find the lateral area as well as the total surface area of this pyramid. It's a hexagonal pyramid because the base has 6 sides. So we want to find the perimeter first. So our perimeter is going to be 6 times 6 because there's 6 sides, making it 36. Our slant height, which is represented by that cursive L, has been provided as 15. So far, we have half of 36 times our slant height of 15. Now we got to go ahead and find the area of our base. This is a hexagon, which means our capital B, area of the base, is going to be found by taking half of the apothem times the perimeter. Now we have the perimeter, so we need to find the apothem. So the apothem is from the center of the hexagon perpendicular down to the base. So this would be a 90-degree angle. This gets split into 3. That makes this triangle a 30 30, 60, 90. So the 3 is across from the 30, so this is our x. Across from the 60 would be 3 square root of 3, which is our apothem. So the apothem, our little a, is equal to 3 square root of 3. So we're going to go ahead and substitute these values in to find the area of our base. It's going to be half 3 times the square root of 3 times our perimeter of 36. And that's going to come out to 93.531. Now we can go ahead and take this number and plug it into our formula. So we go ahead and write this in. So here, the first half is going to be our lateral. And that's going to come out to 270. And this would be centimeters squared. And then we go ahead and find the total, which is going to be the 270 plus the area of the base that we found. And that's going to come out to 363.531. This is also centimeters squared. So this is our total. And above we have our lateral. So then the last part that we're asked to find is the volume. So our volume is going to be third area of the base times height. We already have all these values. So volume is going to be 1/3 area of the base, and then multiplied by the height. Oh, we don't have the height. We got to find the height. So our height is going to be from the center all the way up to the point, and you can cross-section it. If I cross-section it this way, I do have a right triangle. It's just really hard to see at this angle. Now, on the test, you're not going to have one like this. So we know the height, we're going to have to take the square root. This piece here is the slant height. So that's going to be 15 squared, which is also the hypotenuse, so we're going to subtract. The leg, which is going to be what we had for our apothem, 3 square root of 3, that quantity squared. When we evaluate that, we get a height of about 14.071. So once again, you're not going to have one like this where you have to use Pythagorean theorem that involves the apothem on your test. So now I think the pyramids that I have on your test are, I think, square pyramids. Okay, so once again, the way we found this volume, this height here, that's not going to be on your test. Okay, so when you evaluate, we get our volume is equal to 438.69. And this would be centimeters cubed. So on this one, we're going to find the lateral surface area as well as the total surface area. The first thing we need to do is identify what the perimeter is equal to. And since each side is 10 feet and it's a pentagon, 5 sides, 10 times 5 is 50. And then the L is our slant height, which is 14. This right here is going to give us what we need for the lateral. So 1/2 times 50 times 14. This right here is lateral. And that comes out to half of 50 is 25. 25 times 14 comes out to 350. But then we also need to go back and get the total. So we can find this at the area of the base. So area of the base is going to be half the apothem times the perimeter. We know the perimeter is 50, so we need to find the apothem. That's going to be from the center of the pentagon, perpendicular down to the middle of the side, and it makes a triangle. So for this one, we're looking at 5, half of 10 is 5. Now to find this angle, since it's a pentagon, 5 sides, 5 minus 2 is 3. 3 times 180 divided by 5, and then we take that and divide it by 2. That's going to give us this 3 times 180 divided by 5 will give us the area of each angle. And then we cut it in half to find the angle of the triangle. And that's going to come out to about 54 degrees. So we have our apothem is going to be equal to 5 times tangent of 54, and that's going to be about 6.88. So the area of our base is going to be half our apothem times the perimeter, which we said earlier is 50. So we have our lateral, and then our total is going to be equal to, so we calculate all that, and you should get about 522.048. This would be feet squared. And then the last thing we need to find is going to be the volume. And we already have most of our dimensions needed. So formula for volume is going to be 1/3 times the area of our base Okay, so to get this 12.193, we're going to have to find the height of the pyramid, which is different from the slant height. So the height goes from the vertex point at the top down to the center of the base. That's the height. 14 is a slant height. It's along the outer edge. So if we look at this cross section of the triangle that's formed from the height, the slant height, and the apothem, it's a right triangle. The slant height is, so we're able to take the hypotenuse, which is the slant height, 14 squared, minus the leg of the right triangle, which is represented by the apothem. So that's 6.88 squared. Then we take the square root, and that's where this 12.193 comes from. Once again, you're not going to have one like this on your test where you have to use the apothem to find the height. Okay, from here you can type everything into the calculator and get your total volume of the pyramid, which is 699.065 feet squared cubed. So in this problem, we're asked to find the lateral area and total surface area, exact volume, exact answer, which means we're going to leave pi. So for the lateral, we have pi. The radius we know is 5. So times 5, and then our L is our slant height, which is represented by 24. And then if we add in the area of the base, this is going to give us the total. So right here, a lateral. 5 times 24 is going to come out to 120 pi. And then if we're looking for the total, we're going to go ahead and add 5 squared, which is 25 pi. And that gives us our total 120 pi plus 25 pi is going to be 145 pi. And these are in centimeters squared. The last part is asking us to go ahead and find the volume. Formula for volume of a cone is going to be 1/3 pi r squared times the height. The height we were not given. This is the height. Our height, we're going to have Pythagorean theorem. 24 is the hypotenuse, so it's be 24 squared minus 5 squared. And that's going to come out to about 23.473. So when we plug in our value, and by the way, you may have to use Pythagorean theorem on your test. Okay, so this would be 1/3 the radius squared, which is 5, times the height, not the slant height, 23.473. Now, for here, this really isn't exact because the decimal is still rounded, but I'm still going to go ahead and leave pi in the answer, and you're going to get about 195.612 pi. Okay, so here we're going to find the approximate volume and then the total surface area. So starting off with volume of a cone, we're looking at 1/3 pi times our radius squared, and then we're going to multiply it by the height. So we need to find the radius. This right here is a special right triangle. A side across from 60 is 36. So we're looking for the side across from 30 to break our radius. So this is where we're going to take 36, divide by 3, and we get 12, and then multiply by the square root of 3. So volume is going to be 1/3 pi times the radius, which is 12 square root of 3, quantity squared times 36, and this is going to come out to about 783.561, and this is going to be units cubed. Then we're going to find the total surface area. So this is where we're going to be pi times the radius, which is 12 square root of 3, times the slant height. So our slant height here, it's still making a right triangle. This is across from 90, which means it's 2x. So it's going to be 24 square root of 3. And then we're going to need to add the area of a circle, which is going to be pi r squared. R, the radius, 12 square root of 3, that quantity squared. And then type all that into the calculator, and we're going to get about 4,071.5 units squared. So on this problem, we're looking for the approximate surface area of this composite figure. So we're going to need to do the lateral area of the cone, because I want the outer part but not the base. The base is inside. And then we have half of a sphere. In this particular problem, from the diagram that we have, we know we have a radius of 4, a height of 15, but I need to find the L. This would be the slant height. That's not given, but we know it forms a right triangle. So we can find the slant height by using Pythagorean theorem. It's the hypotenuse, so we're going to do 15 squared plus 4 squared. When you calculate that, you should get approximately 15.524. So we're going to go ahead and take all those values and plug them in. So we have pi times the radius, which is 4, times our slant height, which is 15.524. And then we're going to add it. You can reduce the 4 over 2 if you want. So it's just 2 pi, and then the radius is 4. It's approximate, so we can go ahead and round. So we type all that fun stuff into the calculator, and you should get a surface area of about 295.611, and this would be units squared. Then we're also asked to calculate the volume. So here our volume, it's going to be volume of a cone plus volume of half of a sphere. So volume of a cone is going to be 1/3 times pi times our radius squared. And then we're also going to multiply that by the height of the cone. And then we're going to add half the volume of a sphere. Volume of a sphere is going to be 4/3 pi, and then we have our radius squared. So the radius squared. And then from there you type it into your calculator. And this would be units cubed. Okay, so on this problem, we're having to find the surface area and volume of the composite. This composite is going to be half of a sphere. And then we have a cylinder, but only one base is visible. So we need to be careful when we're calculating the surface area. For the surface area, we're going to take this volume of a sphere, 4 pi. This is going to be the radius squared, and then we want half of that. And we're going to add it to the lateral of the cylinder, which is 2 pi times the radius times the height. And then we're going to add one base. So it's going to be pi times the radius squared. So when we type this all out, we get 1093.27 as our approximate surface area. And then we got to go back and find the volume. So for volume, same thing, it's going to be half of the sphere. So I'm going to do half, and then 4/3 pi times the radius cubed, and then we're going to add it to volume of a cylinder, which is pi times the radius squared times the height of the cylinder. Type that all in, and you should get about 2,714.34 meters cubed. So in this one, we're given the volume. So I went ahead and put it in the equation, volume, and this is the formula for volume. You notice that we have the pi on both sides, so those are going to cancel out. So this leaves us with 4,500 equals to 4/3 r cubed. This is where you want to be careful when getting rid of your 4/3. So I'm going to go ahead and multiply by the reciprocal, 3/4, both sides. So these on the right are going to cancel out, leaving me just with the r cubed. And then 4,500 divided by, or multiplied by 3/4 is 3,375. From here, you're going to want to take the cube root. So you type that into your calculator, and we're going to get 15 is equal to r. So we have a radius of 15 millimeters. So on this one, we have the volume of a cylinder. So I have the formula for volume of a cylinder. If we take the information we know, so 402 equals pi. Now the radius is going to be 4. The diameter is 8, radius is 4, and then we're looking for the height. 4 squared is 16, so you're going to divide both sides by 16 pi. And then this gives us our height, which is 7.9975, or you could just say it's about 8 inches. So on this one, we're trying to find the volume of a square pyramid. That square is important because it tells us that the length and the width are the same. So volume is going to be equal to 1/3. Our base, area of the base, is going to be 16 times 16, which is 256. So we're times 256. Then the next part is going to be that height. The height is from this vertex of the pyramid all the way down to the center at that 90 degrees. Because it's a square, I know this length is 8. The slant height was given at 30, and we're going to use that to find the actual height. We're going to have to use Pythagorean theorem. The slant height is going to be the hypotenuse, so it's going to be 30 squared minus 8 squared, and that's going to come out to about 28.914. So we're going to go ahead and substitute that into our equation, our formula, and then we get our answer, which is about 2,467.3, whatever units they are, cubed. Okay, so on this one, we're looking for the total surface area as well as the volume of a trapezoidal prism. It's a trapezoidal prism because the base is in the shape of a trapezoid. So to find the perimeter, we're going to do 20, 8 plus 8 plus 14. And that's going to come out to 50. We have the height of the trapezoid is 6.5. And then the area of the base, or a capital B, is going to be half the sum of the bases. So that's going to be 20 plus 14 times the height of the trapezoid, which is 6.5. And that's going to come out to about 110.5. So when we substitute all these in, we get our surface area is going to be equal to 50, because that was our perimeter. Now this height is referring to the height of the prism. So that's going to be 22. Plus 2 times the area of the base, which is 110.5. We type all of that into the calculator, and we get a nice number, 1,321, and this would be units squared. The next step is going to be to find the volume. Volume is going to be capital B, area of the base, times the height. We know capital B we found is 110.5, and we're going to multiply this by the height of the prism, which is 22, and that's going to come out to about 2,431 units cubed. So in this one, we're told the area is 100 and 225. So remember, this is area squared. If we want to know the scale factor, we're going to have to take the square root. Square root of 100 is 10, and square root of 225 gives us 15. Now 10 over 15 reduces to 2/3. So this is what we're going to use when we're talking about the parts of our similar figures. If we wanted the volume, we would cube it. 2 to the third power is 8. 3 to the third power gives us 27. Okay, from here we know the height of the smaller pyramid, and we're looking for the height of the larger. So this is the scale factor I'm going to use because we're talking about parts. This is going to be 2/3 times my smaller height is 9, and I'm looking for the larger. So we're going to cross multiply, giving us 2x equals 27. When you divide both sides by x, you get about 13.5 inches. So in this last problem here, we're given the ratio of the radius for 2 cylinders, which is 3 to 4. That's our scale factor. Area is going to be 9 to 16, and then if we needed volume, 3 to the third power would be 27. 4 to the third power is going to be 64, which is what we need. So this is going to be the scale factor we use, 27 over 64. The volume that we know is for the smaller, so it's going to be 108 pi, and we're looking for x. Now, I'm going to advise you to go ahead and set the pi aside and just attach it at the end when you're done. So when you cross multiply, you're going to get 27x is equal to, I'll just leave it there for now, so don't forget it, 6,912. My pi is still there. Then go ahead and divide both sides by that 27, just leaving pi in your answer because that's how it's going to be on your test. And we get x is equal to 256 pi. And you're done. Good luck.